me, because that's always good practice is recorded. But that's the one where I went through the whole practice test. All right, so what is this asking? It says write each set in the indicated form. So they give us one that's in the set builder notation and one that's in roster form, and they ask us to write it in the opposite way. So on this one right here, that first one, the first part there where it says, it opens up with the bracket, you got X and you got the line. That's really kind of just all formality. That's just saying the set with X such that X is a natural number and greater than or equal to 3. The most important part is, well, it's a natural number, meaning that it's a counting number, and it starts at 3 because it's got an equal sign. So what do you think we're going to do? Is there an end to this?
No, you put ... You start at 3.
Yeah, generally you do four of them, and then you do ... If there's an end and there's just a lot of them, you can use the ... and then you put the last one. But this one right here just means it keeps on going on and on. So 3,000,005 is also in there too. So that's why you put the ... Now this one is just saying that it's the natural numbers 1, 2, 3, and 4. So there's really going to only be, it could be this one. It could be this one. Let's see, which one is it going to be? Sometimes you might need to write them out. I do think it's going to be this one because what that is saying, oops, no, that's not it.
I think it's the third one.
You're right, because, no, it's the second one. You're right, because you got to watch the equal sign. It doesn't include 5, so it's starting at 4. So the first number that's less than 4, and then it goes all the way down to 1, because the natural numbers end at 1. It would not include 0 or the negatives. If it said integer, then it would keep on going. Morning caffeine fix here. Still morning. All right. So cardinality means what? There's another way of writing it. You write that N of A or N of B. That means what? Anybody got an idea?
The quantity of how much the elements are inside.
Well, yeah, the quantity. In other words, how many in there? So A has got 1, 2, 3, 4, 5, 6, 7. Is that correct? Yes, because the roster set, you can just write them out and see them. Unlike this, where it says less than or equal to -2. I'll say greater than or equal to -2 and less than 0. Now, what I want to do is write it over here, and it's a big pain in the neck to go back and forth. What is that crazy noise? Like a clicking noise. All right, so this one it says greater than or equal to -2. So -2, greater than or equal to -2. That means it's going to the greater sign. So -1, and then comes the friend 0, because it says integers. And that's it. -2, so greater than or equal to -2, and less than or equal to 0. So that one is just 3 elements in there. Diana, just reload it. Like hit your on your browser, the little arrow thing. All right, so let's do some true and false things. All right, remember the little pitchfork means is an element. So the first one, it says 35 is an element of A. So can we go up there and find 35 in that set? They're all listed, so it should be easy. Do you see 35 in there? You got 24 and you got through 30. There's no 35 in there, so this is a false statement, correct? All right. B, we already wrote that out. That was -2, -1, and 0. So that one is true because -2 was the first element. 29 is an element of A is also true because it's right there, the second to last one. All right. So is 5 in that B set? I hadn't done the roster yet, Catherine, so I'll do that towards the end. All right. So is 5 in that one right there? Remember, that was just -2, -1, and 0. So that's true as well, isn't it? Because it's saying 5 is not an element of that. Question, Mercedes? Did it work, Diana? Okay, now we got some that deal with equivalence and equal. Remember, equivalent just means you can't see the board. Can you see my video? I mean, if you can't, it's best to just, oh, well, I'm not doing anything on the board. I'm just kind of going through here. I'll write something on the board if need be. Oh, okay. I see what you're saying. Generally speaking, if something's not audio or video and it's not me doing something foolish or me going offline or something, then generally reloading the session will work. The first way to reload it is with the little circle arrow up there, the reload. The other way, of course, is just to close the session out, go back in and join again. All right. So A and B both have 3 elements each, but the elements are different. Okay? But what equivalence is we can line up each one in the set A with the one in set B. So these are equivalent but not equal. Does that make sense?
I thought it would be equal but not equivalent, because equal
Okay.
means it has the same numbers, right?
No, you got it backwards. Equal means it's the exact same elements.
Oh, okay.
See, look at B now. Okay? These are actually equal because let me go over there to the board. It says greater than 15 and less than 23. There's no equal there. So it was basically this. That's what it's saying. So no equal sign. So it's going to be 16, 17, 18, 19, 20. Wait a minute. It seems like that's something fishy about that. Oh, I'm sorry. It's evens. I thought it was getting too many. So it's evens. So that's what set B is. Crazy brackets. That's what that is. It's brackets. Should probably just typed it out. Okay, so now going back over there, you'll see that both of those sets are equal. So that means that we can say these are equal. Now, here's the thing. If two sets are equal, then they are also equivalent, because if they're equal, they've got the same number of elements in it. So if you ever think two sets are equal, then they should all be also be equivalent. And this is one reason why I had a hard time finishing is because last night is because this thing takes so long to reload. So these are equal and equivalent, because if they are equal, then they're also equivalent. All right, so C is integers greater than 2 and less than 6. So that means 3, 4, and 5. 3, 4, and 5. So there's 3 elements in there. B is a set of integers greater than 2, which is starting at 3, 4, 5, 6, 7. There's no ending. So B is an infinite set, and this one only has 3 elements in it. So these are neither. All right, and then D is pretty much the same thing. You've got 4 elements in here. Now, just on happenstance, if you have one element that's repeated, like if there was 2 D's in that B set, you only count them once. The repeated elements only count once. But this one has 4 elements, and they are different than these, so this is neither equal nor equivalent. Any questions about that? I know that's a hard thing to grasp, because, I mean, it took me a while to learn it. It's just a matter of equal means it's the exact same elements, and equivalent just means it's the same number of elements. But if 2 sets are equal, they're also equivalent. All right, write each, this just says subsets, so that means we're going to take them all. First of all, the empty set is a subset of everything, and then you can take them out individually. Oops, they want you to put this around it, I think. And then the set itself. And the reason why we know that's all of them is because there's 2 elements in the set. 2 to the second power means there's 4 subsets. And we're going to see that again in the next one. But that's just asking us to list them all.
So we would have to use the empty set? If we
Well, yeah, that's one of the definitions. This empty set is a subset of every set. If you go back to the notes, there's one of the, I mean, it was, pretty early on. The empty set is a subset of every set.
But that's probably what I was doing wrong, because I never use the empty set unless it's actually an empty set. Like, I wasn't putting it in with the equation, if that makes sense. Like, I will use like that problem right there. I will put F and E, but I never would add the empty set.
Well, if they're asking for subsets, then the empty set's going to be there, because that's the only way you can get 4 of them. And that's the way you determine. And you're going to see here, look. Now, this one doesn't ask you what they are, because when you got a large set, it's a pain in the neck to get them all. But we know how many there are by that formula. Okay, let me just write that. The empty set okay, and then the number of subsets is the number of proper subsets And I'm going to write them because it's 2 to the nth power. And the n is just however many, yeah, you got to put the commas in there. Now, I was doing one last night, and since I was moving fast, I think I forgot to put a comma after the last one before the ... and it said to do it. So it's not that cruel and heartless. But yeah, generally, because otherwise it reads it differently. All right, so what we got to figure out is, so there were 2 sets over there. There was A and B, I believe. All right, so no, there was just A. I'm sorry, and it had 1, 2, 3, 4, 5 in it. So just go back over and look. Yeah, there was just A. So N just means the number of elements in there. So this is the only set. So it's 1, 2, 3, 4, and 5. So the number of elements in 5. So for the number of subsets would be 2 to the 5th power, which is 32. 32 subsets. And that's why that one previous, it's got a small set, because you'd spend the whole test time if you had to figure out all these subsets. But one thing we do know is for the number of subsets, it would include the empty set, and then it would include the set itself. And then there would be 30 other ones in between that are single ones and double ones and triple ones and all that. So 31 proper subsets. All right, any questions about that? Okay, so let's go on to the next one. Making a lot better time than I did last night because people had questions. Okay. Now this one, invariably, you really need to write it down. I really wish there was a way I could copy and paste these on the board. But sadly, it does not work like that. They don't want you to copy and paste them, I guess. So I figure that's for way to cheat or something. So I'm going to write them here and then write them on the board. If you got any questions, just pipe up or type it, all right? Damn pen here. Somehow. So F, G, H, P, Q, R, X, Y, and Z. There's no real way around writing these down, in my opinion. If I could write on that problem, I could do this, but I don't think you can do this in your head unless you're some kind of person that's smarter than the average bear and shouldn't be in this class, you're most likely not going to be able to do it. So we'll take this one a step at a time. So let me, I'm going to write them on, and then I'm going to type them in over here. Well, I'm going to write them over on the thing, okay? Because I can't really go back and forth. So I'm just going to rewrite the problem essentially. Now, hopefully I got it right. When you do this kind of thing and write things down, that's why I'm a fan of copy and paste. But when you do it like this, it's easy to make a mistake. So GH, Q, or Z. Okay, good. George, are you on some kind of, what are you on, a regular computer, or are you on a like handheld or something? All right, I have to write it. And that's a bracket. All right, so we wanted to find, what was it? It was find out what's an A union B intersection C complement all. Okay. Yeah, I mean, things are harder to do on handheld things. All right, so we got to find all right, so just like most things when you're dealing with math, start on the inside out. So I'm going to go and find B intersection C first. So what does that mean? That means ones that are common, right? So what's common between B and C? G is not, H is not. Looks like Y is the only thing. Check me on that. The only thing common between B and C is Y. H is not, G is not, R is not, P is not, X is not, Y is not.
Mr. Cruz,
Yes?
on C after the P, is that a Q or a G?
Q.
Oh, okay. Okay.
I wish they hadn't done that to either. That, you know. Because you can go back and look at that original problem, and it's Q. Because the P, the Q, and the G look a lot alike. I wish they had used something else. Okay, so now we got to find the complement of that. All right, so what does the complement mean? Humor me on this. The complement means what's not in Y. I'm sorry, in B unions intersection C. So the way I like to do it is just go over to the universal set and take out what's inside of here. And so that one means since we're taking out what's in B intersection C, everything that's left is the complement. So F, G, H, P, Q, R, X, Z. Because now you know you got the complement, because if you take the complement and that set itself and put them together, you get everything back. All right, so now we've got this part right here. If you want to, I'll remember you when I do the roster. So that's that part. Now we got to union this with A. Okay? In other words, we got to take this set and this one here and put them together as one, like one big happy family. All right? I'll come back and put that. So that's the only thing that A adds is it doesn't add anything, does it? Because G and H are in that set, the complement. Q and R are in there, and so is Z. So it's, well, but it's already in there it's in the complement. That's what I'm saying is A doesn't add anything that's not already in there, right?
Yeah, I get what you're saying.
So it's really just that same thing. So that's it.
It's way easier when you break it down.
Well, yeah, you got to. Like I said, there's a tendency for students to try to do that kind of thing, like you can do it in your head, and there are some people like that can do it, but generally it's just not good practice. I mean, because unless you can go back and verify it after C. That's not a comma, that's a complement. That's what we handled right here. See, we figured out what B intersection C was, and it was just Y. So the complement is what we took here. This right here is everything that's not in Y that's in the universe. So it was just everything else. All right?
Yeah, I get it. No, I was talking about, you see how after the parentheses they have a dash on the top? You see where I'm talking about?
You talking about right here?
Yeah. What is
That's
that?
the complement.
That's complement. Okay.
That's everything that's not in B intersection C, which is what we found right here.
Okay, I see it now. Okay, thank you.
Because B intersection C, the inside was just Y. So the complement is everything in U that's not in B intersection C, which is everything else but the Y. Because now, this is the way you check and make sure you got it right. Now you can take these two sets here. If you did this right, and put those together, and you get back the universe. There's nothing in common between those two sets, but they should ultimately, when you union them back, you'll get the universal set back. All right. Okay, so this is another one that's similar. No, that's the old one. Here's the other one that's similar. So this one's going to take a little bit of time because we got to write it out. I don't know of any other way we can do it. So, like I said, I wish they would let us copy it, but I wish there was also a way to paste images on there. And the thing is, there are some boards that let you do that. I just don't know how to do it on that one. Okay, so I'm gonna write them over there, or type them actually, and then find these two different things. B intersection D complement and B union D complement all. All right. Okay, so that's the universal set. B is fairly short, so this is good news. All right. All right, so this one needs the little doohickey on the inside. Okay, so I'm just going to do them in order. So D complement, as I said, is the best way I know to handle this is just to go through and mark out. So I'm going to put over here, because that's the most complicated part. So I'm going to do that first. Let me tell you what. So take out M, Q, and R. So then what's left out? In other words, that's in D. So everything that's left is D complement. Okay, that's D complement. Now, we're putting together the intersection. So on this one, it's just the thing that's common. So what's common between B and D complement? Well, you got an F and you got a Y. That's the only thing. Q is not, and neither is X or Z. F and Y are the only ones. So I'll just write it right here. Only thing common between those two. All right. Oh, thanks, Kenya. That makes me feel good when somebody says the same thing to me and lets me know I'm on the right planet. Okay, so now we got to do this in 2 steps. You first off going to have to find B union D. So we're going to put these two together here into one. That's what union is. Just adding them all together. I'm going to put them in order. You don't have to. So that's everything that's in both of these 2 sets, right? I'm sorry, these 2. I think I messed up. I was looking at that one. So it's F, Q. I'll put the M first. So we're looking at B union D. You got to make sure you're looking at the right thing. F, M, Q, or Y. All right. So that's what's on the inside. Now, I'm going to go up here and make a new set of strikeouts. I probably should have taken the red off, but I can't do anything about that now. So let's just take out F, M, Q, R, and Y. This is working out pretty good because of the fact that it also took out the ones that were there before. So it's X, Z. It's all that's left because it was the complement. All right. Questions about that one? All right. So this one, we shouldn't have to write this one out because it's a Venn diagram. It would be helpful to do it. And I'm right, we'll write it down, but for the most part, we can talk through it. All right, so we got a Venn diagram. And so let me see if I can make that larger. No, I don't think I can. Because it's just the way it works, I can't. All right, so A union B is anything that's in A, B, or in the middle. All right. On this one, you could say the first one is Roman numeral 1. That's 8 is only in set A. 9 is in both set A and B, and 1, 2, 7 is only in B. So the intersection is just what's common, and there's only one number in there. All right. Now here's where you got to pay attention on these complements. This is the way I kind of handle it, is if we just cover up A, the whole of A, which includes that 8 and that 9, what's left over? So verify me for all of those are not in A, right? Because 8 and 9 are inside of A. And if you take that A complement and add the 8 and 9 to it, you got everything. So that's why we know we got. Now, here's where you got to pay attention. This one's kind of a two-stepper. Now, A union B is all of these things. It's the 8, the 8, the 9, the 1, the 2, and the 7. That's what we call the union. Those, anything inside the circles. So the complement is anything outside. Okay? Questions on that one? All right, we're moving pretty good. We might be able to get through all of these, but you can still look at that video because those are different problems because, you know, every time you take this, it's going to change, you know, it regenerates. All right. So let's just answer. These are only one of these is going to be when we have to draw out, fill out the Venn diagram. I think all of the rest of them, the Venn diagram is already there for us. All right. So how many students drink soda?
83.
What?
88, my bad. I couldn't see it.
Okay, it doesn't say drink soda only. It just says drink soda. See, these people right here drink soda. That's 63. So 88 and 63, okay? If it said soda only, then you would be correct, but it's not.
I understand.
Okay, good. So you got to watch that. That's important. Sometimes they'll even word it differently. All right, how many drink neither soda nor tea? Well, all of these people right here, that's what we call the union.
So
Those people drink
223.
what?
233. 233. You
It
see,
says
add them
drink
up, right?
neither. Okay? So what it says is, another way of saying that is, how many don't drink soda or tea? How many are not in that union?
Oh, it might be 63.
No, they drink both of them. The 63 drinks
Oh, the
both of them.
59.
The 59 don't do either one, or they do
Look at me.
neither.
Look at me.
Okay?
I didn't see the 59. Because it's kind of small. Really can't see it.
Okay, yeah. I wish I could make it bigger for. Oh, there's that little calculator on here. I don't know if they put it on all of them, but this is a neat little calculator. How many of the students do not drink both? Okay, this is both. So they only drink one, they only drink one, and they don't drink any of them. So it's the four numbers outside of that center one, outside of the intersection. Okay, we got that? Good. Okay, good, good, good. All right, so this is one we got to fill in and then answer the questions, but this is a fairly easy one too. The 11 is the one that takes a little bit of time. I'm going to go on to 12, and then if we have time, I'll come back for 11. Because like I said, I want to get with you. I got to do the roll, and plus I want to talk to the people that interested in that extension. It's not something I'm going to be able to do every time. It's just for this. You know, we lost that day, and like I said, I don't generally like to do things on holidays. But anyway, now They're giving us three values here. And the one to start with, generally, if you've got it, is the both. So 47 is going to go in there. Now, what this is saying is that the rap section has to add up to 66. So we've already got 47 people that listen to rap. So we got to take 66 and subtract 47 from it. And that means there are 19 people that listen to rap only. Okay, you got that? Now, the jazz circle has to add up to 85. So there's already 47 people in there. So that means this is 38. All right, now, how do you think we can find this? These three numbers right here are the union, okay? You add up those three, that's the union. That's the ones that did one or the other or both. So all of those add up to 104. Now, yeah, good. That's right. So all of the three circles or the three numbers there add up to 104. So we're going to subtract the total number of people that surveyed. These are the people that like, maybe classical or rock or whatever. So all of those four numbers are going to have to add up to this 132. So that's how we found it. Now, how many like jazz but not rap? In other words, they also say it as how many like jazz only? How many like rap or jazz or both? Well, we had already added that up. That was 104. Because remember, the 104 and the 28 get us back to the 30, 132. And this is the one that we want. If there was no intersection for these, if this was 0, then you would use that one. And then you could also use one of these, but they're not in there. So let's go ahead and see if we can finish this baby. All right. Now, if you got the Venn diagram already worked out for you, that makes it like nice and easy. It says how many students drink exactly 2 of these types, 2 of the 3 drinks. Exactly 2. All right, these people right here in the middle drink all 3. These people right here drink milk and soda. Exactly 2. These people, the 138, drink the milk and coffee only. And then these people drink soda and coffee. So I'm just going to write it like this. See if they'll let me. No, they won't. I thought I could just type out everything. What do those 3 numbers add up to? 138, 61. One 38, 61, and 92. Good. How many of them don't drink soda? So if we cover up all of soda, that means the 61, the 103, the 33, and the 92 are gone. And we've only got 15, 138, 34, and 49. So 115, 138, they're also out of the soda ring. The 34 outside of the soda ring, and so also the 49. So that's 336. All right, so we got to pay attention here. How many students drink neither coffee nor milk? Coffee nor milk, but do drink soda. Well, you got 103 and 49. Because all of these people here and here drink coffee or milk. So the only ones that don't drink coffee or milk but do drink soda is the 103. And I'm sorry, we don't need the 49 because it's specifically saying drink soda. So if it just said drink neither coffee or no milk, then it would be the 103 and the 49. So it's just the 103. All right, we may have a chance to finish this thing. So y'all have two good ones to do. All right, so this one, you kind of, they don't necessarily always have one that's all three, so you just got to start with one of the other intersections. So let's see. Now, all the numbers, once we get them in, I have to add up to 692. This one right here, the red circle, is going to have to add up to 448. Neither of those I've used just yet. 87 people own a cat, but neither a bird nor a fish. That's the same thing as saying they have a cat only, correct? All right. So we can kind of take that one out now. If I was doing it on the board, I would just strike a line through that because we already used that. 24 of the people own a fish, but own neither a cat nor a bird. So in other words, 24 people got a fish. So this is probably the next one we want to use. 63 of the people own a bird, but own neither a cat nor a fish. All right. So all of these are gone. Now let's jump down to the next one, because those other ones we still can't use them yet because we don't have enough information. And the next two are going to fill in two more, and then we can go back to these and the last one. So 163 people own both a cat and a fish, but don't own a bird. So cat and fish, but don't own a bird. So that's that one. That's the people that own a cat and fish only. 106 people own both a cat and a bird. Cat and a bird, but don't own a fish. So that's 106. All right. Now, they tell us that 448 people own a cat. Well, since we've got those three there already, we can add those up. So 106, 87, 163, and then we're going to subtract from 448. And that means that the final square has to be 92 because all of those inside the red circle have to add up to 448. All right, now we can get this one by using that last one there. Because what that is essentially saying, when we say at least one, it means the union. In other words, all of these numbers in here have to add up to 569. Now, if I had been writing these down, I might not have to do this, but we got to go and add all the numbers that we got so far. 87, 106, 63, I'm going across the top. And then the 163. Then the 60 and the 92, and then the 24. And so that's 535 minus, well, subtract 535 from 569. And that means 34 are going to go in there. So we use the fact that all of those are at least one, because these folks out here are the nuns. They don't have that. They got an iguana or a, rooster or rabbit or something. Now, or maybe they don't have any animals. All right, now the last one we can find easily by taking this and subtracting that. 692 minus 569. So that's 123. So now they only got one question, but we should be able to answer. How many people don't own a fish? Well, everybody in the purple circle owns a fish, so there's these three and that one down there. So 87, 106, 63, and 123. Those are the no fish people. All right, we've even finished it almost exactly at noon. Okay, so let me do the roster, and those people that, if you got any questions, make sure you can. You can, yeah. That one on there pops up, but it doesn't pop up for everyone. But you're allowed to use the calculator, paper, any of your favorite writing instrument. I mean, the only thing you can't do is phone a friend and ask Hal on the internet. All right, so Essence, I see. Shia, I see. Mashika's here. Kennedy, I see. Naja, I see. Chloe. Javante is here. George, I've seen. Nathan, I've seen. Lena. Diana. Abdulghani. Darian is here. Mercedes is here. Is Mercedes still out there? I know she was here. Lamont Shaw is here. Catherine. Raymond. Where's Raymond at? He's usually around. Karina. Sarah. I see. Is Danielle up there? Yep. Gavin. I see. Kenya's here. Jalen, I'm pretty sure I saw him. Yep. And Latorsha Williams. Okay, so if you already taken the test, or if you got no issues, then you can head out. If you want me to go ahead and work with you on this extension, stick around here and then say something or type it in, okay? Because I got to put your name in and such, okay?